Action!
Hi, and welcome to the latest episode of the Grudge Report. Today, we're going to talk about The Expanse. We're continuing our discussion of season 4, and today we're going to talk about episode 2 of season 4 called Jetsam. My name is Margaret, and I work at the SETI Institute, and I am joined by Franck Marchis, who is a senior scientist, senior astronomer, senior scientist, both at the SETI Institute and Chief Science Officer at Unistellar. You would think at this point I would have your title, but every week it's going to change. So thank you so much.
Every week. You can call me Majesty next week.
Majesty, I'll name you the CEO. That'll be a surprise for Bill.
Title. No problem.
But thank you everybody for tuning in. We're really excited to talk about this episode. I'm going to do my regular spiel to tell you that we're going to spoil everything in The Expanse up to season 4, episode 2. So if you aren't caught up on this season of The Expanse, go get caught up, come back here so that you can listen to our thoughts, specifically the science of this episode. So if you're sticking around, awesome. Franck, we talked a little bit about this episode, and one of the first things that comes up in the episode is Auroras gets a dispatch from Holden, who's on Ilus. He's through one of the ring gates on a different planet, and he mentions, or she mentions, a comms delay. And then, you did some fancy math and had some interesting findings. I think Auroras says there's a 6-hour delay in when Holden sends a message and when she receives it, and she is near Mars, correct?
Yeah, that's correct. So we're going to assume that the transmission is made at the speed of light, right?
Fair assumption.
So it's the distance between her and the source of the message, it's 6-hour light. So what I did, you say, very simple. It's not a heavy calculation. 6 light hour is basically 43 AU, which is the 43 times the distance between the sun and Earth. That's the way we measure the distance in our solar system between planets. We know that the Sol ring, the famous gate that allow the transmission, the teleportation, we call that, between the Sol system and the Ilus system, this gate is located 2 AU away from the orbit of Uranus. So that's roughly 19 AU minus 2. I don't know in which direction, in fact. Then you say if it's closer or further away. So I'm going to say
closer to Earth or further from Earth.
Let's say it's closer to Earth. 19 minus 2, 17 AU. Okay, so, and now we can also assume that it's in Mars. So the distance, what we can say is that the Ilus gate is then located 26 AU from Ilus, the planet. So why this is interesting? Well, it's because the gates, apparently those rings, seems to be always in the outer part. I say always because I have two cases here, but the Sol and the Ilus, they're always in the outer part of the planetary system. They're not close to the terrestrial planet. They are in the place where you can find gas giants or icy giants at 26 AU, or in the case of Ilus, or 19 AU in the case of Earth. So why? That's a very interesting question. Why do they put the gates here, and why not closer to the terrestrial planet?
Well, the gates do have some properties that are a little concerning. We see that in the episode when the unfortunate people who were spaced hit the ring, and I think they disintegrate. So maybe there's a little bit of a hazard.
Yes.
And the ring builder regulators specified that they needed to be a certain distance from any potentially habitable planet. Who knows? But that's very interesting. And we've talked before about delays in travel within the world of the Expanse. It's mesmerizing to me that a message could get through the ring gates in general. So
yeah, the physics here we don't really
understand.
Calculation that is instantaneous. Okay, so that means that there is no delay when they cross between those two, which is apparently what we see for matters. When they cross, is happening like that. So I'm assuming it's the same for photons. But of
Yes.
course, I don't have.
It's not like a wormhole where with wormholes theoretically you are traveling through time, right?
Yeah, there is also this effect that I neglected here.
Right. Okay. I mean, it's still pretty. So this is some really intense technology because they've managed to make it so that there's no change in time when you travel great distances. I feel like we're going to talk a lot about the ring gates and all of this technology as the season progresses. But as we say, Avasarala is on her way to Mars. She spent some time on Mars. There's some political intrigue going on, some politics about traveling through the ring, civilians doing that and populating the planets on the other side of the ring gates. But there's some really interesting dialogue in science around Mars. Franck, do you want to talk about that?
Yeah, they when Sarella is basically leaving a main spaceship and is about to land on Mars, we have a very beautiful view of Mars, the planet, the red planet, and you can see the color, the hue of the red hue of Mars reflecting on the spaceship. But you also see auroras. And she mentioned that. She said, I could not believe that one day I will see auroras on Mars. And she's talking to her husband, and he said, well, that's what happened when you create an atmosphere. So this is not completely true, because auroras are created. I'm sorry to kill this moment, which was beautiful, but
it was beautiful.
The aurora are created by magnetic field. It's particles basically moving into the magnetic field, which are bombarding and impacting and hitting the top of the atmosphere. So to have an aurora, you need to have two things. You need to have an atmosphere, three things: an atmosphere, a magnetic field, and particles. So we do have the particles because they're coming from the sun.
This is the solar wind, right?
Yeah, that's a solar wind. We do have the atmosphere. She mentioned that they created an atmosphere which is denser, but Mars doesn't have a strong magnetic field. Mars has what we call a fossilized magnetic field. So it's very, very faint. And don't ask me the number because I don't remember it. It's very faint.
You said it was a fossilized?
Fossilized, yes.
So does that mean that it's old too?
It means that basically the magnetic field in the planet is produced by the motion of material, the convection of the kind of not liquid but semi-liquid magma. And that's create this magnetic field. That's the way Earth has the magnetic field. You have seen probably the picture of Earth and the magnetic field, which is slightly tilted, and you can see this kind of magnetic
rings
lines
coming out of the poles. Yeah.
So we don't see those. We know they exist, but we don't see them. Those are magnetic line basically. And the particles, what they do, it's super interesting. I did my first intern. As an intern, I studied the motion of particles on magnetic fields. That's why I wanted to talk about this. What they do, they spin around those lines and they bounce back and forth. And depending on how the strengths at the beginning, they basically can reach the atmosphere. And when they reach the top of the atmosphere of the planet, close to the pole, they start hitting the pole. And what you see for the atmosphere, and what you see from Earth is the auroras. Those are basically particles bombarding, coming from capturing the magnetic field and coming to our planet. So to go back, yeah, they're beautiful. And to go back to Mars, we don't have this strong magnetic field on Mars. So I don't think we will see those kind of auroras in the future of Mars, even if we terraform the planet and make an atmosphere. Because making a magnetic field is something that I don't think we know how to do, because we have to change the internal structure of the planet, melt it again, heat it to melt the material to recreate this convection pattern that creates this magnetic field.
Are there there are auroras on other planets in the solar system, right?
Yeah, there is aurora on Jupiter. They're gigantic.
Is it blue? Is that the one?
Yeah, they're kind of bluish. They're UV, so I mean, they're blue for the extraterrestrial being that can see in the UV. And you can also see them in the infrared. We call that the H3 plus emission at 3 micron. There is auroras on Saturn as well. And I think that's all, because the other planets have a weird magnetic field or no magnetic field. So But yeah, there is Aurora also, sorry, on Neptune and Uranus. They discovered them recently, but they're very weird because they're very localized. So auroras are on gas giants and on Earth, essentially. And Earth is very special because of the strong magnetic field and the presence of an atmosphere.
I was going to say Earth being special once again.
Always.
Last time it was about liquid water rain. Now it's about beautiful auroras. Yes, Earth is a very special place. I really liked the scene, even though you did just kill it a little bit in terms of the science. But I think the sentiment is quite beautiful, where Avasarala and her husband are talking about, multi-generational problems and projects, which I think is something that, working at the SETI Institute, where, we're probably best known for searching the skies for radio signals from other civilizations potentially. That's definitely a multi-generational project because there's so many potential systems, and the distance of capturing a signal or potentially sending one back is so vast. It's very interesting hearing them talk about it. And it was very sad. I think it was her husband who said, we on Earth, we've lost this passion for multi-generational problems and doing things, hoping that our grandchildren will carry the torch, which I thought was very sad. And I hope isn't the way things go. But
me too.
Yes. So anything else science-based on Mars?
No, I think that's all for Mars. We have an elephant in the room here that we need to talk about.
You want to talk about Illis?
Of course I want to talk about
Before we talk about Illis, I do want to say something is going on with the Belters. Again, my girl Kamina is doing a great job policing the space near the ring gates. But we also hear, I don't think for the first time on the show, because Naomi has mentioned him, but one of the first times where he becomes quite relevant is Marco, who becomes the main antagonist for season 5. And he even plays a pretty antagonistic role in this season. But we have that conflict brewing in the background with Kamina and her Belter crew. So let's put a little pin in that, and let's talk about the elephant that is Illis. There's so much to talk about and so much that's really cool. Where do you want to start from?
Let's start about almost the first scene. On Illis, when the biologist, exobiologist, we could call her, basically talk about the discovery when she analyzed this famous swarm locust that came. They took one of them, and she's doing some analysis, and she said it's made of metal. And I think Naomi answered, well, then it's a machine. And they say, oh, that's a very terrestrial way of thinking, or something like that. Yes. That's exactly what I will say.
Except she's a belter, and so her response is very funny. But the point is made, right? That's a very myopic way of looking at life, right?
Yeah, so she explained that a bit. And remember, we kind of did some extrapolation in the previous episode, and I think we were completely right, amazingly. We discussed about the fact that the planet Illis formed probably in a different cocoon than Earth, with a different composition. So there is different kind of ratio of material, okay? So on our planet life is basically using carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Those are really like the base elements that are used for every amino acids, everything that make us. And she said, I mean, I'm going to quote her. She said, well, on Earth, we're made of potassium, carbon, and calcium. And this life is made of arsenic, silicon, and iron. So I would have loved this to be a little bit more accurate. I'm sorry. I'm going to destroy the science. I'm sorry to be the scientist here.
Well, what would have made it more accurate? I'm curious, because I really like this scene.
So first of all, life on Earth is not made of potassium, carbon, and calcium. Is made of this mostly carbon, nitrogen, oxygen, phosphorus. And a biologist will have said that first, those 6 elements instead of calcium and potassium. But that's okay. Why not? But then she say here is made of arsenic, silicon, and iron. So if you look each of these elements she mentioned, potassium, carbon, and calcium, if you look at the periodic
table.
So carbon is group 14. A real scientist will have said, here is made of, he will have taken the element just underneath because there is more metallicity, and it's not as pretty, it will be rubidium, silicon, and strontium. Those are the elements which are just below carbon, potassium, and calcium. So since the planet is more metallic, it's likely there is more of those elements. So it's possible that life is made of the same elements. So we're replacing carbon by rubidium, etc., by silicon, and etc. So I'm picky here, but I kind of like that she mentioned that idea, this concept of having life with a different type of elements to build those complex molecules.
I like that too. And I mean, it's interesting because in astrobiology, which is, the understanding of life generally and how to look for it, we have a group of, a sample size of 1, which is life on Earth. So we have to extrapolate what we know about life and the formation of life on Earth when we're looking for it other places. But everyone's very aware that it could be really different other places. But how do you even begin to look for something that is just so different? But I think it's been talked about before, right? Like on Titan. And
but we don't have to go all the way to Titan. You can just stay in California.
Tell me more. This is very exciting.
In 2010, as you probably remember, I don't know how old you were in 2010, but in 2010, we had this amazing announcement by a scientist working for NASA, and I forgot her name. I'm very sorry for that. If you can find it quickly, let me know. She announced that she found in the Mono Lake a type of life which was different to our life because arsenic was replacing phosphorus in the chemistry. So arsenic, once again, there is arsenic and phosphorus in the same group, and arsenic is slightly heavier. So arsenic could could have the same property than phosphorus. So this was a big deal because if confirmed, that will be the first time that on Earth we find a life which has a different type of chemistry, which integrated arsenic instead of phosphorus. So Felisa Wolf-Simon, thank you for finding the name, basically make this announcement, which was kind of a revolution. And I remember at the SETI Institute, we talk a lot about it because that was a big deal, because that would completely change the way we do the search as well, in chemistry, right? It would be a way for us to study, finally, biosignatures of a world which is truly different to ours. Unfortunately, this finding has been rejected now. There is 2 papers that came out showing that, in fact, those bacteria are not replacing phosphorus by arsenic in the DNA. They did some better analysis than what Felisa Wolf-Simon's been doing. And there was another paper that did some analysis and showed that those bacteria could live in high arsenic environment, but without integrated in their chemistry this arsenic. They truly stay using the phosphorus chemistry, the phosphorus atoms, in fact.
So that would be an extremophile that could just withstand a high arsenic environment, but is still at its root very similar.
Like our, made of the same chemistry than ours, but who find a way to survive in extreme environment, which is in the case the Mono Lake in California.
High arsenic. It's interesting because I was speaking to Pascal Lee, who is a scientist at the SETI Institute, who specializes in Mars, because there's been a lot of discussion about Mars and the search for biosignatures given Percy, the rover that is now on the red planet. And he made that kind of a similar point, which is that it would be amazing to find a biosignature or some sort of life on the red planet But what would be even more amazing is if it's completely different from life on Earth, because one, that would, be pretty, we could be pretty sure that there was no cross-contamination between Earth and Mars, that it's completely specific to Mars. And two, because it would just expand the way we think about life, right? It would introduce us to this whole new way of thinking about it. So just I thought that was very interesting. And it's a shame we didn't find any in the Mono Lake, but maybe there'll be something interesting on Mars. Who knows?
I'm gonna drop something. There is papers, one of them published in the 70s, that claims that on Earth there is a shadow biosphere.
That is a hot topic. I feel like shadow biosphere has, every once in a while it pops up. Yeah. Why don't you tell us what it is?
So I don't know much about it because I'm not a biologist, but what they did is by calculating life, the amount of life on Earth, the amount of energy, etc., they found out that there is 10% of the energy which is somehow missing. There is something that creates gas on Earth, that biosignatures, etc., that we don't understand. And this could be due to a shadow biosphere. And the shadow biosphere is made of bacteria, animals, etc., that we cannot see because they are not similar to us, and we don't have yet the instruments to detect them. That's a revolutionary idea, and that will be one of the biggest discoveries in biology if we find one day we prove the existence of this shadow biosphere.
It's crazy to think about. I'd love throw that paper up like they do on the Expanse show. It's very, and it's also, we could go down a rabbit hole, but I mean, there's scientific definitions of life, but I think when you kind of get down to it, it gets a little nebulous of what's life, what's not life. I mean, people still argue about whether viruses are technically alive. So
yep,
that's a whole nother basket of kittens to discuss, but let's stay on Ilus before I take us down a rabbit hole. So we've talked about the comment around terrestrial thinking. What else on Ilus was interesting to you, Franck?
Well, there is the biomes. It's a perfect transition to what we just talked about.
Yes.
So she used the term biomes. Maybe you remember the scene? Maybe you can explain the scene.
Yes, because the first discussion that we just had about, terrestrial thinking and the metallic locust, I guess I'll call it, happens when they're at the camp. And then Holden, Naomi, and the astrobiologist LV, Dr. LV, they go to the structure that is within like buggy drivable distance from the camp to go check it out. And on the way there, they date the structure, and then the scientist has a discussion about different biomes or different types of life on the planet. But I have a feeling that you're going to say that something isn't quite accurate in her description of things. So
you know me well.
Tell us what was wrong, Franck.
It's not wrong. Okay. So in this case, she mentioned that we have 3 biomes on the planet. One is the one that made the protomolecules. One is the local biosphere, so the one that was initially on the planet. And then there is the humans that are coming from another planetary system. So the definition of a biome in biology or in the geology, it's a large community of flora and fauna that occupy a major habitat. And so an example of biome is basically forest, tundra, lake. Those are the type of, that's what represents a biome. So when you go to a biome, you look at the species over there and you try to understand the relationship between the species. So I lost a lot of my time reading or looking around, and there is gazillion of different biomes definition, because biologists are a little bit like astronomers. They love to classify and make maps and so on.
And so subcategories.
Make categories.
All sorts of stuff. Yeah.
So there is this guy, Rich Walter, who created a biome based on the the seasonality of temperature and the precipitation. And then there's another guy with the same name that also made another kind of classification with the region and the temperature as well. But the most recent one is the WWF basically told about those biologists in 1998, okay, we're going to stop this talking of multiple biomes, and you are going to sit at this table, I'm exaggerating here, and in a week, we have a definition of all the biomes. But they did some kind of meetings to decide together what will be the best definition of biomes and define biomes on Earth, on the planet where we have life. And there is maps, you can find them online. You can use Wikipedia. I'm going to show one of them here, where they show the world dividing in biomes, and you can see there is the same biomes in the middle of Australia and in the Sahara, because those are desertic area with more or less the same temperature, condition of life, and there is biomes similar amongst tropical forests, etc. And they also have biomes in the ocean, which are absolutely amazing. I didn't know that, but they are doing this. They have done those maps too.
Well, yeah. I mean, haven't you seen like images of the creatures that live really deep in the water, and so there's no light, and that biome is probably very different from something you would find near the coast, right?
So we don't know much all the biomes that well. Some biomes, like the one you mentioned, we don't really know the details of the ecosystem, who is eating what, the composition, the ratio, the condition of existence of those species. I mean, there is still work to do, and that's the work of biologists to study those biomes. So now to go back to the show.
So she misused biome.
I think she misused biome because, in fact, on this planet, there seems to be mix. I mean, the structure, the black structure that we see around, they're everywhere. The local biosphere is everywhere. And of course, the humans are right now in those camps, but they mentioned that they've been traveling around, etc. So they're not a biome. What I think she wants to say is that we have different type of genesis in this planet. That's the word she should have used. So genesis is the origin of life, basically, the creation of life. The protomolecules, the local biosphere, and the humans were created differently, basically. They have probably different DNAs or different chemistry. And that's the word she should have used, because to describe what's happening on this planet.
Because this is clearly not the creatures, the builders, I think is what they're called in the show, canon perhaps, but the creatures that created the proto-molecule, this is not their home planet. It's a planet that they colonize. That's pretty clear, right? So that's how we kind of know they're a different genesis, because they originated somewhere else and they showed up here, and there was some maybe birds and plants, and that's the local genesis, the life that came to be. And then there are the settlers, who the genesis was on Earth, right?
Yeah. But there is an interesting point she's making in the show, is that those systems now, they are together on the same planet, and there will be some interactions. And we don't really know what's going to happen between those different genesis. The chemistry may be different, but there may be some similarities, such as they will interact. Somehow, maybe the human will be affected by the local biosphere. We know that humans can be destroyed by the protomolecules already, so this may happen. So here we have this interesting planet with 3 different life that's going to mix, and probably some issue will occur. And that's something that may happen soon for us.
In what way?
But when we're going to go to Mars. You just mentioned the most revolutionary discovery on Mars, quoting my colleagues Pascal Lee, and I really appreciate when he says that, because that's true, will be we find life on Mars, but not only find Mars life on Mars, but find different life on Mars. So when we're going to go there, what's going to happen to us? Or what's going to happen to this life? Maybe...
I think there's a whole field on that in terms of Earth, right? Planetary protection. Exactly. Where we are very careful not to cross-contaminate, mostly because we want to make sure that if we find anything that it's pristine. But when it comes to humans, I'm sure some of the same things will be in place, right? We don't want
planetary protection, the first step is to make sure we don't destroy the life. The second step is to make sure that if we bring life from Mars or the moon, they don't destroy us. They have that already in the mandate of planetary protection. So we're already thinking about that. We did not find this life yet, but it may happen. And then what?
Well, and if we do bring samples back from Percy and the current Mars 2020 mission, which I don't think anything's set in stone yet, but if that comes back, I'm sure that they would have to put all sorts of things in place for those samples, right?
Yeah, well, we're already bringing. I know you want to talk about Mars, but Mars is not the center of the universe. We have been getting samples.
I know you want to talk about asteroids.
I know.
Love asteroids. I was gonna get there. I promise. I'm not gonna leave the asteroids out, but go ahead.
We just got some samples from the asteroid Ryugu. The Japanese mission Hayabusa 2 is landed a capsule in Australia. And I'm telling you, they are very careful. They just don't open it and sniffing it like that. They are writing.
You're just sprinkling it around.
Yeah.
Growing tomato plants.
To make sure that there is nothing alive in it, nothing like that could be some kind of dormant life. You know, these bacteria that can stay in cocoon for years or centuries and wake up suddenly when there is water around. So they do the analysis before sharing the samples around.
Yeah, this is like the plot of every science fiction movie, you know, but it's true because you never know what's in it, and you want to protect Earth from it, but you also want to protect it so that the science that you do isn't contaminated, right? Because it's difficult to bring samples from asteroids to Earth. So you don't want to mess that up. Yeah.
But you know, I mean, all this planetary protection is great. It's science first, true. But ultimately, we will go there. So we will probably one day find this different life, and there will be this interaction, and we will have to learn. What we're trying to do as scientists is to prepare the world for that, make sure we know what's going to happen in advance, maybe find some protection, I don't know, some medication that could help us not to have this horrific interaction with another species that will eat us alive or something.
Or the opposite. Mm-hmm. Yeah. We're going to eventually one day we'll do the Grudge report from Mars. That would be cool.
Yeah.
Tune in 20 years. Yeah, we'll be there.
There will be a delay, so we will have to cut.
What is it? 8 minutes? Didn't we decide that?
6 minutes, something like that.
6 minutes. So negligible. There's so much to talk about here. What else struck you? Do you want to talk about the age of the structure?
Yeah, I think that was interesting too. You mentioned maybe you should mention what those structures are, so people relate.
The structures. They look to be built by the builders, the people that made the proto-molecule, and they look almost like Stegosaurus spikes coming out of the ground, and we don't know what they're for necessarily, but Holden and Naomi and Dr. Evie go to check them out because they seem to be the source of the metal locus.
Yes.
So something's going on, but when they initially go, nobody can get in. But they are able to date the structure.
So there is multiple things that I like in the scene. First of all, they use the biologist, and there is this guy on the phone who is probably a physicist or something, and he's basically telling us, okay, you take the thing and you put it against, and you hold it. And it's really what we do sometimes. And volcanologists, for instance, or even astronomers, when you go to observe or to do an analysis of a volcano and so on, of course you don't know everything. Like you don't know all the instruments. So sometimes you call your friends who gave you the sensor, and he basically tell you, okay, so look at it, turn it on, you do that, and it's exactly the scene. I do remember vividly one day, I did some kind of use of a telescope, an instrument I'd never used in my life, and I will use once in my life. And my colleague on the phone telling me exactly what she wishes. You press it, you put it here, you look at this. Okay, I have the data. Thank you. So you're just a robot for them. Okay.
You're there like arms and legs and eyes.
Yeah,
And,
all this
yeah.
PhD for just being. It's okay. It does happen. So they do this analysis and they assume there is the same, I think you use a carbon-14 way of measuring the age of the structure, which is kind of weird, but anyway, there is
radioisotopic dating.
Yeah, something. I don't know which isotope he's using, but he's something. And later he estimated that he's 1.5 billion years old, based on assuming it's the same kind of formation, the same initial radioactivity that we have on Earth. That's interesting because 1.5 billion years old, as you probably remember because you studied that at school, you mentioned that to me, it's which aeon?
I can't pronounce it because I only ever like protoxenonic.
Protoxenonic, yeah. I
got it. I can spell it better than I can pronounce it, I promise.
Yeah, so Earth is divided in aeons, which are big area, and then we have each aeon is divided in era. So I can show you that I don't know them. I've said this is one of the things I've been trying to remember, but I still don't know the aeons. But this one, if we were on Earth, that will be during the Calamine period of the Mesoproterozoic era. People are probably laughing listening to me saying those words. So that's an area in the planet evolution for which the life was very simple. It was very like monocellular life, archaeans, bacteria, eukaryotes. So very simple, diversifying, but quite simple, monocellular, not yet cellular life. And that was just, at the time on Earth, we have one gigantic continent. This life we had mostly also in the ocean started producing oxygen. So that was a long time ago. So if these structures appear 1.5 billion years ago, they basically appear when this planet Ilus was extremely simple in terms of environment and biosphere. There was no yet complex animals floating around, or there is no multicellular life.
There would have been some algae in the water.
Algae in the water.
Maybe some fungi.
Exactly. So that may be the reason it was kind of, they could have an impact. This is science fiction. It's not science anymore. But I can imagine that if an intelligent species arrive on a planet like this, they have only monocellular life, they can still kind of bend the evolution of the life to create the plants, the animal, the fungi, and the dinosaurs or equivalent that they want in the future. And by inserting some kind of changing slightly the chemistry, they can change the evolution. So that may be what happened in the case of this planet.
Interesting. Yeah, because we aren't, at least in this show at this point, we aren't 100% sure what the builders were doing. They were clearly doing something because they built these structures. And at the very end of the episode, the structure turns on and there's lightning. So there's something happening, but my mind immediately goes to like harvesting resources, lithium, which seems to be what the belters are doing. But that's also a really good point. If you show up early enough, you might be able to impact what happens on the planet.
Yeah. So that's all for me in the science. I mean, you probably have seen the scene on Ilus where we can see the moons.
How many moons did you spot?
I spot 2 or 3 of them. And I read that there is way more moons on the planet, around the planets, apparently. Now, that's the moment I look in the sky. As an astronomer, of course, every time I see a scene happening in the darkness like that, what I do, I look at the star to see if there is a pattern that I can recognize, and I look if there is a moon. That's my first thing.
Then you're like identifying things that you look for to kind of orient yourself.
But that's all.
I didn't.
Go ahead.
I mean, that's a lot. It's very, very interesting stuff and very like SETI focused when we talk about looking for life or understanding how it came to be and what could be out there. It's very, I don't know. I love this season because it touches on so many of those things. But we should also mention that in addition to all this cool science stuff, There is also a fight brewing on Ellis, which I think will complicate trying to figure out what's going on with the proto-molecule. The two factions are at each other's throat, and Holden and Amos and the Rocinante crew are trying to be Avasarala's eyes and ears on the ground and keep the peace. But from the way this episode ends, I don't know how that's going to go. And then we also have Proto-Molecule Miller, who is in Holden's head and seems to be spewing a bunch of nonsense at all times. And he's the one that got Holden to go back to the alien structure, chop up some roots. I mean, it is quite funny. I really like the interactions between Proto-Molecule Miller and Holden. And there was just some, I don't remember the exact dialogue, but essentially Holden looks at Proto-Molecule Miller, who's like, you know, some sort of alien technology, some sort of remnant of all the people that on Arrow Station passed away is like powerful. And he says something to the effect of, oh, these roots are getting in your way. And so he has to cut through the root and something happens and some sort of technology is turned on, which I think we'll get into next episode. So
all right.
There's a lot of stuff going on. I think this episode may be quite long, but hopefully everybody who tuned in found it interesting. Let us know in the comments below. There's also a plethora, a whole smorgasbord of links and buttons you can click beneath this video if you want to stay tuned or learn more about the SETI Institute or get notified when new episodes of the Grudge Report are on air. So thank you for tuning in. We've mentioned the SETI Institute a lot this episode, and just a reminder that we are a product of the SETI Institute. The Institute is a nonprofit research organization, and our mission is to understand the nature and prevalence of life in the universe. So, as I said, we're a nonprofit. If you are so inclined, please feel free to donate, and we will see you next time. Thank you.
Bye-bye.
Bye-bye.